Welcome back to the channel, guys. So previously we have built our AI agents using Python and manual tools. We have then improved with LangChain. We replaced the Python tools with LangChain functions, and finally I think now we are ready to move on to LangGraph. So LangGraph is even better version built on top of LangChain. So you had to know LangChain to learn LangGraph properly. So what is LangGraph and why it's needed? And so I've built a comparison chart for all the three. You can do things with Python and LangChain, but I think in 2025 you are better off using LangGraph for your AI agents or workflows. Okay, so this is a simple comparison. Python, there is no abstraction. You write the code, if else. You write the conditions, for loops, while loops, and you use the tools directly, get the response, etc. For LangChain, we replace those functions, those loops, with some functions provided by inbuilt libraries inside the LangChain. For example, we had to call OpenAI API by ourselves with Python, but in LangChain you just provide the LLM that you want to use, the model, and it will make the call to the LLM itself. But in LangGraph, there is even higher level of abstraction. Even the functions that we use in LangChain can be replaced with newer functions. So we'll get to it. Creating your AI agents with Python is okay. With LangChain, it's far better, and with LangGraph, it's the best way to make AI agents in 2025. Python, if else, for while. LangChain is chain-based architecture, so you have one function that calls another function, and the chain goes like this, CD. Meanwhile, in LangGraph, you can have nodes. So it's a graph-based architecture. You have different nodes, A, B, C, D, E, and at each node you can have conditional edges. So each node could be a deciding factor to go where after this. So after C you can go to D, and after D you can go to A, or you can go to E. So these are conditional workflows, and you can create more complex graphs using LangGraph. Also, you can understand LangGraph with an example, like a hotel management example. You can start your graph from is booked or not. For example, your customer asks your customer chatbot that can you upgrade my room? So your chatbot can go and check if the customer has booked or not. If he has booked, then check the booking number, you get the room number, and check if the room is upgradable or not. If it's upgradable, then good. If it's not upgradable, then return a generic response, and you can end the conversation here. And if it isn't booked, you can directly give the generic response that we don't do this, or please escalate it to a person, right? But this will be a bit complex, so we'll start with a simpler example. So I've made this simpler example. For example, let's say you have a chatbot for customer support, and your customer asks what's the weather today. It's a weather chatbot. So in LangGraph, now here comes a explanation for simple components in LangGraph. There are three parts. State is where you will store whatever variables you want. State will be shared across the graph, right? So this is state is basically a dictionary. You have keys, input, route, and you have their values. What is the weather today? Route is the answer. So this is just a dictionary, nothing else. And after the state, this is shared by the whole graph. The graph is made out of nodes as well as edges, and now these edges could be direct edges, or these could be conditional edges. So let's say these are nodes. Each node will have a function attached to it. Decide, like when your code is on this node, decide what to do is that it will run a function that is attached to this node. When the code is running on retrieve node, then it will run the function attached to it, as well as answer will have its own function. So each node can have a function that will be run when your code reaches that node. And edges could be let's say these connect different type of nodes. So these could be conditional. So let's say decide we have two routes. Your customer asks what's the weather today, and you can either go and retrieve weather from an API call like weather app or some news station, and then generate a response to your customer's query. But you can also do that directly if the customer asks some kind of stupid question or some kind of question that is not related to weather, then you can directly generate a response and end the conversation right there. So that is another way to do it. So I'm gonna be using this example with code in LangGraph to explain how it works. So let's get started. So here we have our code. So this is the graph I'm trying to create in LangGraph. So forget everything up until now. You have a customer and the customer asks your weather chatbot, what's the weather like today. This is it for now. Just remember this, right? So we'll be running these different type of questions. So user could ask what's the capital of France. Our chatbot has to handle these type of questions also, and it can ask is it going to rain, check the weather. So all of these kind of handling you can do with different type of conditions. You could do it with Python and LangChain, but as it gets more complex, you won't be able to scale with them. So that's why LangGraph is needed. Let's start with the example. So from top, all you have to do is install LangGraph, pip install LangGraph. You can do this is enough for this video. You have already installed previous libraries. So just importing the libraries, defining the state type of state. So this is just type. This has nothing to do with code. This will be just used to give type to arguments like you do in TypeScript instead of JavaScript. So Python, you have to do it this way. So like I said, each node will have a function attached to it that will be run when your code reaches that node. So let's say when your code reaches decide node, we have, let's say, 3 nodes: decide node, retrieve node, and answer node. So decide node has this function that will be run, and whatever happens inside it, you can do any kind of logic inside this function, and then you have to return the state. So each function attached to a node will return a state. You can change the state based on it. So whenever your code is on certain node, it will have a certain state of this graph, and it can do conditional. It can move to the next node using those conditions defined in the state, right? So you have a retrieval node, logic inside of it, and then it returns the state again. You have answer node, same thing, 3 nodes, 3 functions. That's it. So how do we create a graph? So in LangChain, you have a state graph, and you give it my class, my state. So my state is this class, simple input, route, docs, and output, 4 keys in a dictionary, right? So it's very simple. Just give it the type and have an object initialized. So now we add 3 nodes. It's simple add node. You can do object.add node, decide the name of the node and the function attached to it. So we create a retrieve node, attach the function. We create an answer node, attach the function. We have to set an entry point. So this was it. So decide will be the entry point and answer will be the end point, right? So this is the function, set entry point, decide. So our graph will start from this node. Just a second, let me explain this. We know these edges are fixed from retrieve to answer and answer to end. So retrieve to answer, this edge, and the end edge will be making this answer node as the end, and this is fixed, so we can add these 2 edges directly. So simple add edge, retrieve to answer, and simple add edge, answer to end. Now we have conditional edges. So this is not defined from the start. We have a source node, decide. So from decide, make an edge. This is the anonymous function lambda. Currently, whatever the route inside the state is, so we'll have our key route inside the dictionary state. So if the route is retrieve, then create an edge from decide to retrieve. If the route is answer, then create a edge from decide to answer. That is it. This is conditional. So these lines will represent these 2 edges based on what route is currently in the graph. So route will keep on changing. It could be answer, it could be retrieve. So based on that, the code will have to move from decide to that node based on this condition, right? So we have created our graph for now. This is it. This simple code: add nodes and add edges. That is it. To a set of instructions, right? Now what I'm gonna do is dry run the code from all these functions. Let's say the user asks what's the weather like today. So what you can do to start the node is graph.invoke, and you can put the initial state inside of this function. So initial state will be this input, and what's the weather today, this will be the value, this is the key. We can start here and we get the results, and the results is also a dictionary. It will keep track of what we do in the graph. You will see, right? Let's start from here. Graph.invoke with input, what's the weather like today. So what our code sees is that we are starting entry point is decide node. So we go to the decide function, decide node function. This is the function. So at this point, the state has input, what's the weather like today. So the weather is present in user input, right? We get the sentence from the user, and the whether this word is present in the input. So what we do is create a variable route, and we return the state with a new key route, and that route is representing retrieve for now, for this case, right? So this is just a spread operator. It will preserve the previous keys that were inside the state, and this will return a whole new object. You can learn about Python call by value and call by reference. That's the concept. So we are returning a new object here with the previous keys and a new key called route. So now this, our state has a key route which is retrieve. So now we go to a conditional edge. We are on decide node, so we check all the edges on this node, and one by one, so we check this, we have to come to this condition, and currently the state route, this function will return retrieve. So retrieve will create an edge from decide to retrieve node. Now we move on to retrieve, right? Simple code. You go to retrieve, you at this point you can make an API call, or you can make a database call. It's your choice. And let's say I've received this data from local news website, or let's say you can scrape Google for it, whatever you do. I just written hard-coded data. You can make you can do whatever you want here. Then I just create another key docs and add this data inside the docs object, right? So this, and return the state with the previous keys as they are. Now we are on retrieve, and there is a single edge to answer. So we move on to the answer node, and we do the same thing. We can at this point we have in this inside state we have docs, and we have route. So we can sort of generate a better answer with GPT LLMs. In docs you can like spread out the object into different parts, and then you can create a proper paragraph, proper sentence for user to understand, and then you can say whatever you like, or you can create new type of responses, not the generic ones, and then you return the state again with the key output and your generated answer. And now we are on the answer node, and we know the answer node ends. Now this is the first example that we run. It went to the retrieving weather information, and we hard-coded the answer, so it retrieved the hard-coded answer, and output you can generate anything. So let's say another example is what a user asks something different than your chatbot is built for. User asks what's the capital of France. So this will generally break your chatbot response. It will give, it is not in our scope for the customer chatbot. So what you can do is the weather is not present. We go to decide node. Weather is not present in the user input, so it directly converts the route to answer. When the route is made to answer, the state, we have this this code. So state, this will return answer, and for answer we create an edge from decide to answer. We move on to the answer node directly without going to the retrieval node, and we just create a generic answer for a user that I can help you with various questions for weather information. Please ask about weather. So if a user isn't asking about weather, then you can just give him the generic response. And this is the second code. So we have retrieved nothing. We didn't even go to the retrieval node. We just directly move from decide to answer. And finally we have again another question. Let's say user asks, is it going to rain? Check the weather. It will do the same flow as the first question, and the answer will be same as before. It will go to retrieval, retrieve some data, weather data from some API, and then give it back the answer. So this is a simple 3-node chatbot that either gives you information about weather or it doesn't. Let's run this code right now. So this is the response anyways. You can check this Git repo directly, or you can set up yourself. You will learn more that way, but I'll just include this file in the repository. That's easy to run. So in the next video we'll try to create a more complex chatbot instead of a simple 3-node chatbot and multiple conditions, but this will be the base logic. Only 3 things: state, nodes, edges. That's it.